Okay, so homework assignment for today was to write the make change function, and then we're going to turn that into an object today. But so make change takes a double as a parameter, so some amount of money for a cost, so $5.95, so 5.95, something like that. And a double for payment, how much money you're giving them at the cash register. Maybe you hand them $6, and then it would display to the screen. Notice it's displaying something, not returning something. Display to the screen the correct breakdown of the most efficient change that can be given in terms of dollars, quarters, dimes, nickels, and pennies. So you only have to go as high as dollars. So if something costs $2.31 and you give them a $100 bill, they're going to get a whole bunch of singles back. Is the idea there. Okay, so let's go ahead and write this again. The return type here is void. Why is it void? Okay, well, yeah, we're not returning anything, but what are we doing here instead? We're displaying some stuff. Not returning it, but displaying it. Very common mistake beginning programmers make. Okay, so we're not going to actually spit back a value. We're just doing some stuff and displaying it to the screen. All right, so we need to go through and figure out, first of all, the difference. Okay, so we need to get amount of change that we're handing back, right? So the cost, for instance, if let's say it's $5.95, and let's say we hand them $6, and we can presume that the amount they gave us was more than the cost. It's okay if you want to assume that. If you want to ask the question, if you want to say if payment is less than cost, then you can do some sort of error statement like system.out. Yay. Not enough money. Something like that. You didn't have to do that, but if you wanted to error check your inputs and say, if they didn't give you enough money, scream at them. Okay, otherwise, if we're inside this else, that means we have enough money and we need to determine what the difference is. Okay, so first of all, how do we figure out the difference? If it was $5.95, so 5.95 was what they passed in, and payment is $6, so 6. The difference, the amount of change we should give back is 5, right? Now, one thing you could do is you could take whatever they passed in and convert it to pennies first. And take the payment and convert it to pennies. And then start working with pennies, right? Pennies is your change. So maybe we say something like, because pennies would always be an integer, correct? So if I say int pennies is equal to cost times 100, and before that I need to say payment times 100 minus cost times 100. All right, now payment and cost are both doubles, right? We know that those doubles, when multiplied by 100, will give us whole numbers, correct? But it's still going to, if I have something that's of type double, and I multiply it by 100, my result will be something of type double. So 5.95 times 100 will be 595.0. Does that make sense? So if I want to turn that back into an integer, what do I need to do? Okay, cast it to int. So we're just going to throw in the front of these guys little parentheses ints. So give me the integer version of this value, the integer version of this value, and now I have a number of pennies. Okay, total number of pennies. So at this point, that would be correct change. I can hand them a big pile of pennies. But what I really want to do is I want to whittle this down to dollars first, and I want to whittle pennies down, right? So int dollars is going to be equal to what? If I have 595 pennies, as a human, we look at that and say, oh, well, we should be giving them $5, right? if that was the change, $5.95. I understand in my example that the change would be a nickel, but let's just assume the change is $5.95, 595 pennies. Okay, I would give them $5. How did I get that 5? How did I get 5 from 595? Divided by 5. So we're going to take pennies, well, you'll get divided by 100, right, to get us the 5. So we'll take pennies divided by 100. So pennies divided by 100 will give us the integer division of number of pennies divided by 100. So that gives us a number of dollars. Now, I want to whittle pennies down, though. So if I take $5 out of pennies, how many pennies should I have left? If I have 595 pennies, and I take $5 away, I'm taking 500 pennies, I should have 95 pennies left. How do I get the 95? So I get the 95 by saying pennies mod 100. What is left over after I've done an integer division, pennies divided by 100? So this will give me 95 if my pennies was originally 595. That make sense? All right, next thing we have is quarters. Okay, so a quarter is going to be the new value of pennies, because pennies has modified, correct? Pennies is now down, in our example, is now down to 95. So it's going to be current value of pennies divided by 25. Then we'll say pennies is equal to, and let me show you a shortcut thing here. So I can say pennies mod equals 25. That's the same thing as saying pennies is equal to pennies mod 25. Just a shorthand. This is called a compound operator. All right. You never have to use it if you don't want to, but it is legal shorthand if you want. Okay, so this line and this line are very similar to each other in terms of their effect. Differences is one of them. I'm getting the remainder by 100, the other one by 25. All right, then int dimes is equal to pennies divided by 10. Pennies mod equal 10. Nickels is equal to pennies divided by 5. So however many pennies we have left over, we're whittling down pennies here. Then pennies mod equal 5. And then the final value of pennies there is the correct value of pennies after we've whittled it down. Correct? All right. So we'll do some print statements now. So system.out.println. We can go ahead and say let's do dollars first. So we can say dollars, maybe put a colon there and a space. So there's dollars. I'm going to steal that line. Quarters, dimes, nickels, pennies. All right, that all makes sense? And again, we're displaying a bunch of stuff to the screen, not returning values. Okay, so let's go ahead and test our make change here. So I'm going to go ahead and I'm going to call make change, and let's pass it, we'll say a cost of $11.99, and we're going to give them 20. All right, so we should get what, $8.01 back. Okay, so let's go ahead and run it for this. There's my $8, no quarters, no dimes, no nickels, and 1 penny. If I give them $22.31, just be more creative with it. Well, that would be a very weird amount of money to hand them. It's like, that'll be $11.99. Okay, let me empty my wallet and pockets.
It's entirely possible. Though I worked at a grocery store for 2 different grocery stores for about 4 years. It happens.
Yeah, I know. I mean, I've seen things like where somebody will give like $20 and like 3 cents or something like that, so it rounds to the next dollar or something.
No, but they'll do. Maybe they won't do that exact thing. Like
yeah, I get it. They'll make the math work so they get an even number back.
Sometimes, but sometimes they don't know.
Oh, sometimes just cause.
Just because they don't know.
They just hand you coins.
Yeah.
Like here's some money and here's some paper money. Here's some coins. You count them.
You count the coins. Like, okay, this is $3 in coins, but there's about 40 different coins here. There might be 1 quarter to make it easy.
Including like Canadian money, and they got some rupees in there.
I live 3 hours from Canada, so.
So possibly. Did you accept Canadian?
We kind of accept Canadian pennies because Canada quit making them. They don't use.
So you treated them as a collector's item?
I don't. I might swap it out on the register. Just put like that. I might just have that Canadian penny just sitting out or whatever.
I see.
If we don't lose any money then. Even a penny had any worth, it wouldn't be. What about Canadian times? I don't think they have any of those.
Well, you wouldn't know. They're all like the same size.
Yeah, but they feel they're different.
Almost.
Yeah.
They weigh less.
Exactly. So one of those found their way into my wallet, and I, didn't realize it until I went to get something from the vending machine.
Yep.
And
it
wouldn't accept my dime.
Oh.
Like, why is it? Oh, it's Canadian.
Yeah. Moral of the story: we need to get rid of.
Well, I mean, reasonably speaking, we probably need to get rid of all physical currency.
True.
And just, I mean, we almost already have done that, right? With debit cards and credit cards. I mean, the only reason I even carry cash on me now is for like tipping.
Yeah.
Right? And now we're starting to move towards apps that make it convenient for that. Like I put pressure on them at the country club where I golf. I say, I don't carry. It's true. I don't carry cash on the course with me. I have it in my locker there. So, when you go to take your clubs in, they got some people there that like clean your clubs and put the clubs away for you. And, it's manual labor. You give them a couple bucks, right? I don't have any money on me. So it'd be great if I could like PayPal them, or, they had a little Apple Pay station there because I have my phone on me. Well, I can't use Apple Pay. If you haven't heard the bad news, I switched to Android.
Why did you go for Samsung and not like OnePlus or something?
I was wondering.
Because I wanted the giant screen. I mostly use my phone for digesting video. I'm using for email and Slack and stuff like that, but I watch a lot of like YouTube videos and Netflix and stuff like that on my phone. So I wanted the biggest screen. The other thing is that I do a lot with VR, and this is compatible with Gear VR. Yeah. And I'll tell you what, it's because the previous, I already had a Gear VR, but we had like this old Samsung Galaxy 6, if you guys have seen us demo it before, and it overheats in about, 15, 20 seconds. You can't do anything.
Is that the 8 then?
This is the Note 8.
Oh, okay.
So I was in VR last night for, 2 hours on this, and still had like 80% battery life and never overheated once. So totally worth it for that. Plus, if you're looking for an unsafe feature, it allows you to have 2 apps open at once.
Yeah.
That's the advantage of kind of the Note, the bigger screen ones.
A lot of Android.
Only the bigger ones, yeah.
Yeah.
So I had Netflix going on top, and then my GPS on the bottom.
Oh.
So like while I was driving. Yeah. I was doing research
While you were driving.
I was on the way to the chiropractor, so if I got in an accident and knocked anything out, I was going to get fixed. It's fine. No, actually, where it benefits me, so because I don't subscribe for YouTube Red, where it lets you go to the background, is a lot of times I'm listening to stuff on YouTube. I don't need to see the picture, right? But I want it to stay alive.
Just listening to some GDC presentation.
Whatever it is, yeah, or usually it's like Last Night Tonight or something.
Yeah.
Good, wholesome Christian.
Yes.
Yeah.
All right. Oh, speaking of which, I need to get the Bible verse up for this week, right? I'll get that up today. Okay, so make change appears to be working. Huh? That's kind of the point. Well, I think I've told you guys this before. That's why I do live programming in class. It's that you see it's possible. When I was in college and I took, programming classes, I had already been programming for a while, so it wasn't so much for me, but I saw my classmates, the teachers in there, they would explain stuff to you. They'd write a couple of things on the chalkboard, but you wouldn't actually see stuff work. They didn't have computers that projected under the screen. So what ends up happening then is, first of all, I'm still waiting for my first syntax error. But in general, most people have syntax errors all the time. This is a joke. So wouldn't it be completely reasonable that a teacher writes a whole bunch of code on the board and they're going to introduce some errors into that, right? Forget a semicolon, whatever. And now you're just, copying it down like crazy. And in the end, it's like, oh, well, how am I supposed to learn from his errors or something like that? So usually, I've been pasting the code up onto Slack after class, haven't I?
Yeah.
I think usually I do that. I put it up. So that way you have the exact code we worked with from class on Slack. So it should be error-free, unless I purposely snuck an error in there, for testing you, of course.
Or for copy purposes.
For what?
Copy purposes. Because a lot of times, old copyright, how they would do it is like...
Make one little change?
Errors. So it's like, okay, if I go to page 6, line 7, is that a semicolon out of place? It is? Okay, you stole my thing.
Yeah, and we used to, when I first started teaching, I was at Western Illinois University, and this was in, I guess, 2000. So this is, I guess, my 17th or I think it turns out to be my 18th school year, whatever it is. The class I taught effectively this course in, actually it was probably the 200 equivalent course. It was this giant lecture hall. We had 170 people in there, all right? And we didn't have a projector. Dry erase boards weren't a thing. So we had chalkboards, but we had one of you've probably seen them in, I think I've seen it in Doctor Who or something. They're probably still somewhat common in England. But there was a wall of chalkboards, and you can send a board up to the top. So I had 3 boards to work with. So I would write on the first board, and you shove it up to the top so it would go high. So I'd have a program that would be 3 boards tall. And then after students copied down one thing and you needed to erase it, you pull the top board down, and that became the next line of your program, and you throw that up, and you just keep continuing down. And of course, I never had an error on there either, but that's the point of live programming, is you get to see the problem-solving process and that stuff. All right, so questions about that one. So here's that function, right? And this is 250. It actually doesn't look like I've been pasting code. I definitely do it in 470. I usually paste code. I don't know why. Oh. Maybe we haven't written that much in here yet, but for now on, remind me if I'm, because I intend to paste everything we write just so you have a reference to it.
What's the untitled that you just have there?
Which?
With pasting leaves in red or whatever.
Oh, this guy?
Probably. Yeah.
Yeah, this is from the 470 class. This is scheme. the programming language theory class. You have that to look forward to. Yeah. So for those of you who think this stuff is hard, you haven't seen anything yet. Okay. So let's go ahead, and I want to talk about these things just a little bit. So I'm going to dump some of our values. Today I want to talk about the difference between class methods and instance methods, because at this point I've kind of said, oh, just put static out front just cause, right? Something like that. Let's give some rationale behind it, because in reality, I'm going to delete everything except main and the function we just wrote. If I were writing this code, let me minimize this so more of it's on the screen. If I were writing this, I would not write it this way. Up top here. This is not the way I'd call that function. I've written it that way just because it works and I didn't want to explain it to you yet. I would call the function this way. So this guy is a static function. So static, and let's give some definition to it first. Static versus non-static. Static belongs to the class in which the function was defined. Only exists once. Called by the name of the class in which the function was defined. So actually, I guess the better way of writing this would have been like that. That's what static implies. When I say something is static, I'm saying the class itself owns this. And I'll show you what that means in a few minutes. I'm also saying I only intend for this guy to exist once. It's kind of like a factory. In fact, sometimes you'll see in some programming languages, they'll have something built in that's a static function called something factory. It's meant for performing a task, but it's not specific to an instance. And I'll show you the other side of it here in a few minutes. We're going to look at both sides today. And then we need to know how to call it, because one of the skills that's really important for us to work with any programming language is being able to read documentation. If I go ahead and I open up the way I always get to the Java documentation, I go into java.sun.com. So you can see I already have it in here, but I'll show you how I get to it. And this is a very dated way of getting to it because Sun Microsystems no longer exists. Oracle purchased them. So I go to java.sun.com, which will take you to Oracle's website. And I'll go ahead and blow that up a little bit. Then over here on the right, you want to go to Java SE. Then over here on the right, under Java Resources, you want to go to Java APIs. And then for Java Standard Edition, that's what SE stands for. Click on the newest one, so SE8. For anything we're doing in here, we'll make a difference. Just with each new version, I'll show you here in a second. We have not looked at the Java documentation yet, correct? This is the first time we're looking at this? Okay. So I'll go ahead and click on Java SE8. This is what the Java documentation looks like. I'll blow it up a little bit. Okay. So up top here, we have all of these libraries. Now, the one that we have access to without doing anything special, so the one that we've worked with up to this point is called java.lang. So kind of going back into our code here, there is a little invisible line up here called import java.lang.star. All right. So that is available to us. If I hover over that, it's probably giving us some sort of, it's telling us I've never used that that import, but punchline is that it was because it was already in here. So what I have access to down here is everything that's included inside of the core Java language. That's what java.lang is. This says, give me everything from java.lang. That's what the asterisk says. But you never have to write this line, all right, because we're not often, well, we automatically get java.lang. Things that we will have to write before too long, in fact, we'll probably write it, we maybe even write it today, is like java.util.star, something like that. So there's a utility library in Java that has some stuff in it. The thing that we're going to use relatively often is the random number generator. Remember last semester we did some random number stuff? That's where it lives here, is in java.util. Okay? But the point is that by default we have access to the core Java language, which has stuff in it. But we go back here, you see, here's java.lang. If I click on that, this shows us all the stuff that comes with the core Java language. Now, while there's several lines in there, it's not like a ridiculous number of things, right? We have access to like strings. This is what gives us our primitive types, stuff like that. Now, up top here, there's a lot of libraries, isn't there? And many of those libraries have far, far, far more stuff in it than the core Java language. So the point is that Java is really big. You know, when you get the Java Standard Edition, the amount of crap that's in there is a lot. And the difference between Java 1, Java 2, Java 3, Java 7, Java 8 is as things come out, as new features, new technology comes out, we need our programming languages to have built-in tools for helping us to more easily deal with them. So as an example, just because something that's up here right now, you know, probably, I don't know, let's call it 10 years ago or so, XML was very popular. All right, we've talked about XML in one of the slides at some point. Not in here, but probably in 200. Yeah, so, you know, XML stands for Extensible Markup Language. All it is for data representation. So it's a way for us to say, you know, for example, an XML document would look something like, I might have a name, and then inside there, I might have F name is Mike, L name is Littman. So I've marked up. The actual only data here is the Mike and the Littman, right? But I've wrapped it in some things that kind of give some definition to it, give some meaning to it. So I call these data representation languages. So this guy is an example of XML, which was very popular, let's call it 10 years ago. Why is that not copying? Command C. Nailed it. So if we were going to write the same thing, so today the popular, let's say, replacement to XML, it's not that XML is dead, but if you were writing something today that needed data representation, you would use something called JSON, okay, which is JavaScript object notation. And the same version of this in JSON whatever. There's some sketchy capitalization in here, but that's these two are equivalents. So we would say that JSON looks cleaner, right? There's less bulk to it. We would also say this looks, typically the people that are using these data representation languages are programmers. We're taking something, you know, something getting transferred over the internet in this format, and then we're parsing that out. We're pulling out the first name, we're pulling out the last name. Okay, so usually it's programmers that are working with these things. Now, while this isn't necessarily hard to read, there's a whole lot of fluff in this one, right? Doesn't this guy down here kind of look programming-esque? Looks a lot like our curly brace-based languages. These are just name value pairs. So this reads pretty easily to a programmer. But we do need, I mean, we could write a program that takes this in as a string and parses out the details from it. We can write something that takes this in as a string and parses out the details from it. You know, looks for opening tags, looks for closing tags. It's not impossible to write, but it takes some time. But in today's world, if you're writing a professional application, it's fairly common for you to have to deal with data in JSON format or possibly in XML format. Therefore, wouldn't it make sense for a programming language to have built-in tools for digesting data in that format? So when they release the next version of the language, they're not going to change the if statement or the while loop. They're really adding libraries. They're either bug fixing old stuff if they've noticed some bugs, or they've added some libraries or expanded some existing libraries to give you some tools that are useful in whatever's happening in the world then. Okay? Say this again? Unless it's Apple. Oh yeah, Apple with Swift did start removing loop types and stuff. So it was kind of ridiculous. But in any case, back to the documentation. So there's a lot of crap up here, right? So I've been programming in Java since the language came out. So this was 1994, something like that ballpark. And what I usually tell people is, I program in many, many different languages, even on a single day. But what I tell people is I've been programming in Java since the day it came out, yet I probably have only ever seen 10, 15% of the language. There's so many of these libraries that I've never had a need to use. So wouldn't you agree then that an important skill set is being able to read the documentation so that when I need to find a tool in the language to solve a problem that's maybe different than a problem I've solved before, I'm able to read the documentation and then go and apply that tool. So kind of like when you walk into Home Depot, you got a home project or something like that. You walk into Home Depot because you need a certain kind of tool to solve the problem. And most tools, especially the hand tools, you kind of look at it, you kind of figure out how you're supposed to use it, right? Just because we've used tools before, we get a pretty good idea of how you're supposed to hold it. They kind of have hand grips in different places. They might have a little picture on there, but because we're humans and because we've used tools before, we can make a pretty decent guess on how something might work. Well, programming languages are unambiguous. Therefore, when we look at them, there needs to be a very consistent way of describing how a function works, that kind of stuff. So I'm going to go ahead and I'm going to go into this class called character as an example. All right. So this is inside of java.lang. I've still clicked on that guy. So way up here, here's java.lang. Here's my class called character. Now, so notice here we have a class for booleans, bytes, character, double, float. What are all those guys? How would you describe booleans and characters and floats and doubles? What kind of animals are those? They're primitive types. Okay, they're primitive types. So, but when we create a char, we do something like this. We say char C is equal to A, something like that. We don't say character, we say char. This is built into the language. Okay? And this is, we're kind of talking about this whole idea of static and how it's owned by classes and that kind of stuff, and I'll connect the dots here in a second. This is a primitive type. What's the definition of a primitive type? Well, those are our integers. So our integer types can hold both signed and unsigned values. Our primitive types, you remember that's byte, short, int, long, float, double, char, boolean. Okay, those are our primitive types. So these are types built into the language that can only hold a value. That is to say, they lack the talent to do other things besides holding a value. So if I have a char, I have a character A. There are several things I might be interested in having some tools in my programming language to do. I might want to know if it's an uppercase character. I might want to know if it's a lowercase character. Now, if you had to write a function for whether a character is an uppercase character, how would you write that function? Let's go back in here. So we're going to write a static function, Boolean. Call this guy is uppercase. It's going to take a char C as a parameter. So this guy's going to return true if C, whatever character I pass in, is an uppercase character, and false otherwise. How would you write this? For example, if this was a homework assignment, how would you solve this problem? The who? But you don't know those yet. Let me re-ask the question. How would you solve this problem using only what you've learned in class so far? Let me see if somebody else answers before you. Go ahead.
Can you do two strings, one with all lowercase and one without uppercase?
Okay, so you want to have a string with all the lowercase letters and another string with all the uppercase letters, and then you said then switch it. How would you switch it?
I said search.
Oh, search for it. Find out, is the character in there? Oh, okay. Yeah, fair enough. So really, if we're determining if this is uppercase, we really only need all the uppercase letters, right? Because we're going to go through and say, is the guy in there? So she wants to create a string called upper that has Is it possible for you to go through the alphabet without doing the little sing-song thing in your head? I should take it a step forward and sing it out loud while I'm doing it. And at the end, you're, now I know my ABCs. But really, just keep a straight face the whole time while I'm doing it, so it almost gives off that creepy vibe. All right, so you see, we create a string that has all of the stuff. Oh, but we have a problem here. Remember, our thing is we can only use what we've learned in class. So how are we going to search for it in here? If you don't know which? Okay, well, so this guy so we do have a function for strings that we'll look at today. Well, either today or next class, one of the two. That will allow us to look at an individual character in a string, but we don't know how to do that yet. So her solution is a good solution. She just, she'll have to run back to Home Depot to pick up some more tools in order to solve this one. Okay, but instead she has to solve this problem using whatever tools she has laying around the house. But this would have worked. She wanted to create a string with all the uppercase characters in it, and then just walk through that string and said, does the first thing equal to C? No. Does the second one equal to C? If I find any one that equals it, go ahead and return true. If I've looked through everything and I haven't returned true yet, return false. So what's an alternative approach to this that we are able to do today? Go ahead.
You might have to deconstruct that letter into its actually binary, and you have a table for all of them,
Okay,
ASCII.
in Java, it's not ASCII, it's Unicode. Okay, Unicode, which is a superset of ASCII, right? So we have 65,536 unique values, and you said you want to deconstruct.
Well, now we have to just compare it to the
Okay, how would we compare it?
Yeah, equal sign with the left.
Okay, well, so tell me, what's the nature of a char? How are chars represented in our programming languages? Well, at the end of the day, it is going to be binary, right? At the end of the day, our computers store binary, but it's really a number, right? Because we talked about chars as being unsigned 16-bit integers. So it holds the values between 0 and 65,535. So somewhere out there, there's this big chart, as you point out, Unicode chart. And it says character 0 is this guy, character 1 is this guy, character 2 is this guy. So the char type holds those numbers, and then we look up, because we notice that the type is a char, we go and look up that number on the chart, and then get the corresponding character associated with that number. That make sense? All right, so really my chars are numeric types. So how can I tell whether C, whatever char is stored, what is the value of C? Right here. What's the value of C in this scope? Yeah, it's anything. Somebody is going to call this function. Somebody is going to pass a character to this function and stored inside, and that character will be stored inside of C. So the current value of C is some char when I'm in this scope. And I want to know if that particular char is an uppercase letter. Well, what's my smallest uppercase letter? A. Okay, we can use the actual numeric value of it. So couldn't I also do this? Could I also return C greater than equal to uppercase A and C less than or equal to uppercase Z? There's no red squiggly screaming at me. Okay, so that's, from a beginning programmer's perspective, it's always a good thing. No red squigglies were good. Back, we didn't used to have red squigglies when you did this out at DOS. And actually, before that, we programmed with the chisel and stuff.
Well, it was nice. I like this compared to what we used for Python last semester because that didn't show you anything.
Depending on what editor you used, some of them would.
The one that we
Did we use Atom in class?
We use that.
Yeah.
it didn't show us.
I think there's a setting in Atom where it will do text highlighting for Python,
Okay.
but I
You
don't.
have to first save it as a .py file,
Okay.
and then it'll do text.
Punchline is once you've programmed for a while, you're going to fill into your niches. And I decided I hate web programming. I like the programming aspect of web programming, but I don't like making interfaces like look in HTML. I hate that. I think it's stupid. So I let other folks do that stuff. So I don't use a whole lot of those text editors. So I'm just as happy using like VI out of the command line for text editors. So I would say my skill set at all those inner workings of Atom, all the things it's capable of doing is going to be very limited because I haven't used it often enough to take advantage of some of those things.
For GCC or Clang?
Say this again?
GCC or Clang?
Oh, well, GCC.
Correct answer.
Correct answer. Well, what came before GCC?
Well, maybe.
What was the original C compiler? It was on Unix,
Yeah.
just CC. Hence the GCC. GCC is the GNU C compiler. C compiler.
GNU complete compiler.
I don't.
Includes C++ and Steam and a couple other things.
It's possible you're right. I'm not 100% positive, but I thought it standard for GNU C compiler. That's what would make sense based on that it was upgrading or the open source version of CC, which is C compiler. GNU compiler collection. So we're all wrong. Well, he's right, but he Googled it. Okay, but in any case, why can we do this? C is a char, right? That guy is a char primitive type. We've already discussed that chars are actually unsigned integers. So that guy's a number. At the end of the day, under the hood, that dude's a number, right? What kind of value is this? Cat, dog, double, float, string, char. Char, how do you know? I give you too many. Should have just kept going. Here's your 63 different choices. How do you know that guy's a char? Single quotes around it. Okay, this is another important skill set. I think we talked about this last class too, right? Really important skill set is being able to look at code and know what it's doing. Okay, I really can't emphasize this enough. I mean, I know from a beginning programmer's perspective, you're so worried about being able to write the code yourself. I promise you, you're not going to be able to write code correctly until you can read code easily. Make sense? So when you look at somebody else's line of code, it's not something you're memorizing. It's something that you're reading like it's, a book. So as you walk through this, you're resolving these things. You're saying, oh, okay, return. That means something's going to be spit out of this function. That's what a return does. Okay, I'm returning a value. What kind of value am I returning? Well, let's look at this first guy. What is that? What kind of value is C?
It's a variable.
It's a variable. Okay, that's the correct answer. It's a variable. Variables hold values. What kind of value does C happen to hold? Holds a char type. Okay, so this C here will resolve to its value. So a variable resolves down to its value. In this case, C's value will be a char, some char. And we know that chars are actually numeric types. Okay? Now so greater than or equal to, we know that works for numbers, right? And even though at a glance we say, oh, this guy's a char, we also know that chars are actually numeric types. Therefore, so far so good. We can use greater than or equal to for comparing chars because under the hood, they're numbers. All right, so far so good. Then we get to this guy, and you told me this is the char literal. And the reason you knew it was a char is because of the single quotes. Okay, and what do I mean by literal? It's like a kind of something you'd see in like a book or something. When I say something is a literal, so for instance, this is the literal 5. It's the integer literal 5 as opposed to this is the char literal A. Now there has to be a beginning, right? Somewhere inside of our computer we have the Unicode character set, right? So Java has this Unicode character set. And inside that Unicode character set, we have all of our chars. Those are the literals. They're built in. They're hard-coded. Right? So 65,536 characters, unique characters, are hard-coded into the Java programming language. Those are literals. And we also have a whole bunch of digits that are hard-coded. Maybe you've heard of them. 0, 1, 2, 3, right? Those are given pieces of information for us. Okay? If we don't know about numbers and we don't know about an alphabet, we can't really write a whole lot of software. Okay, so we have to come to the table with some sort of basic skill set that predates the concept of programming. All right? We don't have problem solving without this idea of a language. So we have a numeric system and we have an alphabet. Okay? In here, we're using English alphabet because that's what I'm familiar with. Several of you are familiar with alphabets beyond that. I know a couple of Spanish-y symbols and stuff. But, all right, so in any case, this is a number. Is that number greater than the number associated with that guy? So that's going to be a reverse lookup on the Unicode table. It's going to go and find the A and get the numeric equivalent to the A on the Unicode table. So I'm saying is whatever the Unicode value of this guy, is it at least as big as the Unicode value of this guy? And is whatever the Unicode value of this guy less than or equal to the Unicode value of Z? I'm asking is the whatever char C is it somewhere between A and Z inclusive, all uppercase? That make sense? Now, this was one line, so not horribly hard to write, but it did take us kind of a minute to think about how we wrote this, right? And we certainly could, with more tools available to us, we maybe would have solved this problem a couple different ways. So, her suggested solution was perfectly fine. We just didn't have the tools around the house. In this case, we happen to have the tools to solve it. This solution is faster than hers, but hers might be in the more easily understandable. Just like, oh, I'm going to search through all the uppercase letters. If it's any one of those, we're good. This one requires understanding of how chars are actually represented. All right, so this wasn't overly difficult to write, but if I'm asking in the big scheme of things, might it be helpful for us to find out whether a character is an uppercase character? Is that a tool that we would hope they would just sell at Home Depot? Not something we have to go home and build ourselves? That'd be nice. mean, we obviously don't expect Home Depot to sell everything. You don't go into Home Depot and buy a house. Well, yet. I think you can buy one at Costco. But generally speaking, we're buying subsets of things at Home Depot, right? So there is a limit to it at some point, but the same thing goes here. Home Depot has a whole bunch of tools. I should go into Home Depot and say I'm advertising for them. I have little pop-ups on my videos. It's, brought to you by Nabisco. All right, so Home Depot has a whole bunch of these tools that are used for solving problems that are common problems, right? We want the right tool for the job. So it would make sense for us, for something like this, to find out if a character is uppercase. That sounds like something that might be built into the language. All right, so let's go and look at our documentation. And we're going to look at the character class here. And when we scroll down, so when I click on the character class, it's going to give me, here's the Unicode character representation. You can read all sorts of crap about chars. I promise you it says everything I've already said. Okay? Then you're going to come down here. Don't worry about these nested. So any words, any like title headings that you haven't heard of before, just ignore. Pretend like they don't exist. We don't have that skill set yet. Okay? So like I don't know anything about plumbing, so I'm going to stay out of the plumbing section of Home Depot. Okay? But I can use a screwdriver and stuff. All right, same thing with fields. We don't know about them yet, but we're getting pretty close to that. So forget about that. Let's get past those guys. Keep scrolling down. We don't know about constructors yet, but we will soon. And you've heard of constructors because you heard about them last semester. You also heard about fields last semester, but don't worry about those. Now we're down to the methods. We know about methods. We've been writing functions for a little bit. We wrote them last semester. We've been writing methods for the last couple of classes in here. Now, specifically, forget about concrete and deprecated methods. Deprecated methods just means old methods. Don't use these. But we have static methods and we have instance methods or non-static methods. Okay, but I'm just going to leave it as all methods right now because that's going to kind of show the case. In fact, actually, there's going to be probably very few, if any, instance methods. Much smaller number of instance methods. You'll notice that there's a whole bunch of static methods. Okay, and I'm going to ask you why that is here in a few minutes. Okay? So we're going to go down here, and there's going to be a function here called isUppercase. Or just isUpper. I think it's isUppercase. IsUppercase. Name of the function is isUppercase. It takes a character as a parameter. It returns a Boolean. And it has static out front. That keyword static is the most important part of this function for us to know how to call it. Since it's static, it belongs to the class. It only exists once, and that's going to be a pretty important thing to answer the question I said I'm going to ask you in a few minutes. Okay? And it tells us how we call it. We call it using the name of the class in which this method was defined. What class was this method defined in? It was defined inside of a class called character. So we call this method by saying character dot isUppercase because this method is defined as static. Because it's static, it's owned by the class in which it was defined. The name of the class this guy was defined in was character, so we'll call this method by saying character dot. And all of that is because of this keyword static. So inside of here, I could return character dot isUppercase. Just pass it the C. I've effectively passed the buck. Go ahead.
So it had two listings for isUppercase. What's the difference?
Does the other one take an integer? Yeah. The other one takes a Unicode value.
Okay.
So you can pass it an int 65, and it'll tell you whether that is a representation of an uppercase character.
Okay.
We will talk about this, but he's referencing here is we actually have two versions of isUppercase. You probably heard this if you come to any of our computer science get-togethers. It's a pretty common question. what does it mean to have more than one function with the same name but a different number and or type of parameters? It's called polymorphism. We will talk about that again when we get into this, but we have two functions, but they can tell which one we're calling depending on whether we pass it a char or whether we pass it an int.
And I'm assuming that it considers more things uppercase than just capital A through capital Z.
I don't know if that's the case. I bet you it's well, it would be well, this is coming from a point of ignorance. I assume that most natural languages have upper and lowercase letters, right? So anything that is in any other language would be uppercase, would return that. But so would the char version of that. It just might be more difficult to write the char version of that depending on what keyboard you have. If you're on an American keyboard, an English keyboard, you're going to be limited to English language keys. I had that happen. I don't know if he's still here or not. I think he graduated now. But he had a MacBook, but it had all Arabic keys on it. That was very. He would bring it in, and I was like, I'm having problems with this. And I had to figure out where the key representations were. It's just a very interesting experience. Okay, so since that guy was static, we call it using the name of the class in which it was defined. So I said character dot is uppercase. Now the method I wrote here is also called static. Is also defined as a static method. Therefore, how would I call that method using that rule? So the first question I would ask, is this method a class method or an instance method? It's a class method. It's owned by the class. Make sense? Then I would ask, how do you know? And then you would say, because of the keyword static. We know this guy is a class method because the keyword static is there. Okay, how do you call class methods? You would say, using the name of the class in which the method was defined. What is the name of the class in which this guy is defined in? This guy is defined in character. We wrote this guy, right? We wrote, this is uppercase method for us. This could be called elephant for, so if you want to have these not confused with each other, just because they happen to have the same name, we can call this elephant here. We wrote the elephant method. What's the name of the class that houses this elephant method? Driver. So we would say driver dot elephant, and then pass it our character. That would be true for all the other functions we've also written. Down here, this make change is also static. Driver dot make change, passing it a cost, so you can say 10, passing it a payment, 20, something like that. The correct way to call these guys is with the class name first, followed by a dot, followed by the method name. Why? Because they are class methods. But now we saw that we did not have to use the name of the class. Why?
Because it's local. Because we already have the name, which holds character.
Forget about the character stuff. Forget about this I don't want to confuse the character stuff for a little bit. Just get rid of these. So as of right now, I only have make change. And I can call make change either of those ways. They're the same. Why is this allowed? Why am I allowed to omit that? And actually, I'll say it's functionally the same, but actually this one is faster. And this is a really important concept here, and this is going to fall into that category of most programmers, even people working out in the profession, will have trouble answering this question. Okay, for a pretty similar reason for the answer he gave. The answer he gave was, oh, because it's local. Well, we'll call that it's a third of the way there. Go ahead.
Make change belongs to driver class. You have to specify which class.
Okay, because we're in the class? Okay, so you're saying because we're inside of the driver class, we don't need to specify that, right? Okay, so I'm going to create a function down here, void blah. All right, so when I'm down in here and I'm trying to call make change, this function here is a non-static function, correct? Therefore, this guy does not belong to the class. He belongs to something called an instance of the class. All right. I'm actually surprised that Eclipse is not highlighting this as red. This should be a runtime error. So this guy is an instance method. This guy is a class method. So your answer that we're inside the class, we'll say you're halfway there. The kicker is this. The keyword static that's here says that we are currently in a static context within the driver class. And what that effectively means is there is an implied driver dot in front of function calls. Sometimes you'll get an error message in some languages that will say something like, cannot use an instance from within a static context. And unless you understand this concept, that error message will be meaningless to you. It's like, oh, well, what does it mean by static context? Static context says, I am currently inside of a function that is a static function, and I'm trying to do something in here that doesn't belong to the class. Instead, it belongs to an instance of the class. I don't have to say driver in front here because I am in a static context and I am calling a static method from the same class. That's kind of along the lines of what you were saying. This adds a couple of the extra little details in there. Now, having said that, why is this line actually performance-wise? Not that we necessarily can, but why is it actually faster than this line? Go ahead.
Because you're not having to check, okay, so what class am I in again? Okay, so find the class that I'm in, and then go find that function. It's like, okay, go to that class, get that function.
Yeah, you don't have to search for it. This is me telling Java exactly where it can find that function. So if let's say you left your keys inside, and it's in one of three places. And it's what the saying is always in the last place you look. Right? So you check place 1 first, not there. Then you check place 2, not there. Then you check place 3, you finally find it. So you had to check 2 places before you found it, right? Well, when I just call it like this, it's going to try to resolve that function. And when it tries to resolve that function, it's going to say, okay, well, I'm going to look locally. So it's going to look inside of the current scope. And it's going to bounce up scopes looking for that function. That makes sense? So because of that, I had to go on a hunt to find this guy. Well, Java had to go on a hunt to resolve it. In this case, I told him, oh, I left the keys on the table. This is exactly where you can find them. So I'm actually saving Java some time with the lookup. So besides performance, what other advantage does driver dot have? When I say driver dot, it gives me a list of all the static context stuff in here, including make change. So I can just press enter on it. It types it out for me and tells me what the parameters should be. That's handy. You'll make less spelling errors. Things like that. Okay. So that's beneficial as well. It's never, if you have a static method, it's never incorrect to call it with the name of the class in which it was defined. I recommend you always call it that way. It's faster, you're less error prone with it, and it just looks cooler, I think. It's more of a vanity, fashion sense type thing. In this guy here, I'm actually calling this from a instance context. So if I say this dot make change, actually that is actually really interesting. This it would really surprise me if that works, because what I just explained to you is accurate. It appears like if you're inside of the same class, because it's not making this off limits. So I can call this 10 and 20. Okay, it's giving me a warning here, but does that mean it's going to allow me? Well, I still think it's going to give me a runtime error. It's just not highlighting it the same, because in this case, this is kind of equivalent to driver, but it's the instance context. I'll talk more. We're probably going to have time to talk about it next time, but that's coming from the instance context. With that in mind, if I'm in an instance method, an instance context, I have access to this variable called this. And I'm using that variable to call my make change method. But make change is not owned by an instance of driver, it's owned by driver itself. So I could say driver.makeChange, that's perfectly legal. Nothing wrong with that. But if I leave the driver off in front of that, there's an implied this dot in front, which is not correct. Because when it goes to resolve this at runtime, it's not going to be able to find an instance method called make change. And notice when I highlight over this, it's giving me some possible fixes. Okay, I can say change access to static using driver dot, like we just saw. I can remove the static modifier from the function, so I can make the function an instance function instead of a class function. What's concerning me a little bit is that it's treating this as a warning rather than an error. Let's just find out here. Oh, see, I can't even call that function to begin with because I don't have a this dot here. I would need to create a new driver first in order to call the function. So I would need to say driver d is equal to new driver, and then d dot blah, something like that in order to call it. So I'm interested in whether or not this dies, but it actually won't die because, well, no, I think it still should. It ran. I don't think it would have done that in Java 7. Here's blah. This is an instance method. I'm making a static call because this is a static function. And that should be an error. Yeah, so what's interesting about this, and this kind of goes in the direction of some of the things that Java has done, but I don't agree with this. This is a common I'm going to call it mistake that programmers make. They get confused between static context and instance contexts. And with that in mind, what ends up happening is they make a mistake like this. They try to call the make change function using the instance context. So when I say this dot, make change should not pop up on there as an option. It is showing me it's static. It's putting a little S right here. But it should not be an option. It's not valid to call make change from this dot. That's not an accurate way of calling it. I don't know. I find that very interesting that they're allowing that. So I'm going to officially teach you that that's not correct programming, even though it looks like it'll let you get away with it. It's giving you a warning, but it still seems to work. Yeah, I don't like that. But in any case, the correct way to call a class method is using the name of the class in which the method was defined. So here's our class method, a static method called make change. I'll call it by saying driver dot make change. I can pass it 10, 20, whatever like that. Okay. One last thing in 10 seconds before I let you go. I said I was going to ask the question of why why is there a class named character that has static methods in it? Why is there a 2 uppercase method that's static, right? As opposed to an instance method? Why does that exist in the first place? Why does the character class exist, and why does it have a whole bunch of static methods in it? I'm going to ask that question as a quiz at the beginning of next class. So for next class, you should attempt to answer that question for yourself. That's going to be the question. Why does a class named character exist, and why is it filled with class methods? Given what we have said the definition of a class method is. Right here. So I'll go ahead and put that quiz up in here so you'll see it for next time. But in any case, I will see everybody on Thursday.